Cool. Yeah, a bit of a downgrade from last time, I guess, in my opinion. But it's not John or Alice, but I'm here to talk about like just an implementation I did of something in Rust, and I think it's neat. You can follow along. You'll get through some of the less neat things that I've done, which is fun. But first, like, who am I? My name is Troels Hoffmeyer, the middle name I just got, so I'm getting used to it. I'm an embedded software engineer at Bang & Olufsen. We make those beautiful speakers down there. Buy them. So yeah, in them there's like Linux and a giant C++ code base. And my day job is finding bugs in that giant code base and fixing them and making it run better. And at night, while my kid sleeps, I enjoy my life and write Rust code and make magic in it. Yeah. And by the way, interrupt, ask questions if you're like, oh, but who are you really?
Who are you really?
Fuck. Just like my short journey through Rust. I tried looking back in my Git history, like when was my first commit of anything I did with Rust. I think it was like 2021, which is when I first committed anything in one of my like random repositories. I think that's when I found out about it. And to be honest, like I immediately fell in love. It solves all of my gripes I had with C++. It has like, finally I can build without CMake. Yeah, of course, Conan, like, I don't know, any build system. It has nicer types, it has as nicer safety, like I don't have to wade through the shit as much. And you know the rest, I'm not here to like preach to the choir. And then a couple of projects I've done through that journey, like I've done a Connect 4 solver. Do you know that game? You put a small brick in a 7x8 grid, and you have to like connect 4 so they're in a straight line. And I did like a, what's it called? Like a search tree through that, trying to figure out who wins and what's the best move. It's quite neat. Like did a bunch of stuff to make it run fast, like bit masks and algorithms that I didn't know existed. Then I've done a dbus TUI. I don't know if anyone uses dbus, but yes. Join the cult of dbus. Fuck. But I needed this thing because we run like dbus on our devices, and it's sometimes just a pain to have to like get a GUI to remote into that device. So I made a TUI. Now, yeah, I can.
Introspection tool? Or
Yes, yeah. The dbus is like the intercommunication process in a lot of Linux systems. So if you ever like encounter system D, which is a nice system, the way you interact with that mostly is with dbus.
But this one does introspection calls.
Yeah. So all of like dbus services has an endpoint where you can introspect them, and you get a nice XML or a nice XML, and then you like parse that, have to like figure out which objects are in there, call introspect on that, and do a whole recursive thing. It's still missing some stuff, like I can't call the methods, I can only like show what's in there, but it was neat. Then I've done this hex map I'm going to show you, and some advent of code. And one of the things I'm fiddling with right now is like an open API code generator. We have like a C++ code base, and generating from a YAML into that C++ is nice. So I'm trying to do that. Yeah. Let's get started with hex maps. I'm actually going to start with like what was the reason why I went with hex maps, because it's a nice story. I found these tiles. These are like hexagons. I call them hexes for short. And they're like for board games. So each of them have like a city or some water and a city, and it's made by this guy called Hexes. And actually, like I found him like 4 years ago. I randomly stumbled upon this post on D&D Next, and he was like, I've made these small tiles, and I think they're neat. And I like saved in my memory bank of, oh, that's a neat thing. Then I read like Dungeon World, a really good RPG. I can recommend it. And one of the things in there is like they have a description of how you can role play with cities. Like, okay, I'll store that. That's a neat thing. And then I found Bevy. It was like it's a game engine. It's really neat. I was doing Rust and I just stumbled or some posts explained this, and I was like, this is a cool thing. I'm not a game developer. I imagine myself as someone who likes, who could make games, but it's not really for me, I guess. But Bevy is really, really neat. Just a short thing about it. It's a game engine written in Rust. It's an entity component system. I don't know if that tells you anything. It's really simple. It's code driven. So a lot of the things that I got annoyed with other game engine was like, you write your code and that the code is the truth. You don't have to like drag and drop and then put the thing in the thing. You write your code, which fits my brain very well. And it's just super well designed. Like I like all of the interfaces. I think it makes really beautiful code. I haven't like done anything complex in it. Maybe it's shitty after a while, but yeah. And then amazingly, like it runs on Linux, Windows, and the web. And you might scoff at me and it's like, what, Windows? Who runs Windows? I have my like gaming PC and I like writing code and I can do that there. Really cool. And I can cargo run and I get a window with graphics in it. And I can do the same on Linux. I get a window with graphics in it. I don't have to do anything special. It might sound like, that's not special, but wow. I've tried like getting things to work with C++ and graphics, and it's just horrible. And you can also like compile it to the web, like WASM. Really, really cool. And they're about to release 0.12. I see it like in their Discord. They're gearing up to do it. So go have a look. And just like, this is the kind of code that I use with it. This is my world. So I have like a couple of a setup system that runs when the game started playing or the first time. Tear down on exit of the playing and game over. Have a board generate event. And I have some like systems that run on every update. So player camera control, generate board, and spawn board, and keyboard react. And that's kind of really like the glue of my program. Yeah. So all of this like together, this Hexes guy making these tiles, Dungeon World, and then Bevy. I had this like amazing idea of, I'll make a game where I create cities with these tiles, and each of the cities has like an economy, and I'll simulate it. That never went anywhere. Like, let's be honest, I'm never gonna do that. But I made like a small generator for the maps. So the first thing was me creating actual like 3D objects. Used Blender, their Python API, and then like stamped textures on all of those. And I could then drag my mouse and press like a spot, an empty spot, and I could rotate it, and it was very manual, and it was fine. I then actually emailed Hexes because I found out he's Danish, and I was like, hey, I made this tool. Do you like it? And he was like, really excited. I can recommend like getting people excited really motivates you. When people are like, "Oh, I just made this for fun," and someone actually made a thing out of it, it actually kind of made me happy. And I asked him, "Can I use this and put it up on GitHub?" He was like, "Yeah, go ahead." I actually paid like $10 for each of the sets of hexes, so I gave him some money as well, which I guess he appreciated. But then, like, this was very manual, and it's like, it could be fun just to really just generate it automatically. So I went and implemented a generator for this, and in the meantime, I switched over to using the 2D tiles, because I realized that they're not as legible when they're 3D. So if they're just 2D, it looks nicer. And I had really no reason to make it 3D, I found out. But the cool thing is, in Bevy, I just more or less just fiddled with some stuff, and then it was 2D. It's like, okay, cool. Let's see my first generator, actually. So this is it. It runs in a browser. Boop, boop, boop. And for each of them, I can generate a neat thing.
What's the distance box?
That's where the constraints can't be solved. So, like, he didn't do an exhaustive set of all of the possible tiles, so some of them are just missing. And instead of like doing a backtracking, I just leave them. So the deal is like, for each of the hexes, they have a side, and that side is like water or grass, or let's see, here's some shrubbery. And I then need to like, for each of them solve, okay, what can actually be here? And then put a random thing that can be there, in there. So how do I do that? So some basics. Here's how I represent like a hex. A hex is some sides, a name, and a rotation. So you can rotate a hex. The name is just the thing I use to look up what the actual texture is. It's maybe not that efficient. I could use a handle to a texture instead, but whatever.
And what's the UID?
I'll actually come to that. Good question. It's an identifier for the assets that can be used to generate the thing. And then a default implementation of it is like the sides are an array of 6, and the side, like its default implementation is it can be any side, and it's rotated. So what is a side? Like, side can be one of those like bits and pieces, like an ocean, grass, forest, hills, road, and any. Any is when it's not been actually set in stone yet. So here I tried to draw it. These two, this hex has been like set in stone. I have chosen a hex for this. And for this side one, all of these haven't been determined yet, but this one has now. So any is the black ones, and then blue is, I guess, ocean. And then to check if two sides are equal, I check if it's any other thing. Can anyone see a bug here? It's partial eq. What is the requirements for partial eq? It needs to be transitive. That means that if A equals B equals C, then A equals C. But if desert and then mountain, or a desert and then any and then mountain, then desert isn't equal to mountain. So I have a bug here. I know that, and I thought it was funny to just bring that in, because it actually caused me problems when I was doing my tests. Not because like Rust did anything fancy, but I think my test was just, I needed to compare them instead of actually comparing them, because the transitive properties failed. But yeah, and again, like hex sides is a type I'll use a lot. It's one of these sides times 6 and a small array.
So how did you solve that bug?
How do I solve that?
How did you solve the bug with having faulty constraints on the? Did you switch to another trait? And
No, I didn't.
Okay.
Like,
I use the trait acceptance.
I just accepted that it's only like a problem with my tests, and there I just like memory compare the two. It's just I think it would be a bug like further on, maybe, but in this case I don't care. It works. Yeah. And then, like you asked, what was the UURD up here? No, that one. So for each of those like tiles, I need to like say, I need some format for saying, okay, I have a tile that has like a road here and a green here and some ocean here. And then I used RON, if anyone knows that. It's Rust object notation. It's just, it's not because of anything. It was one of the things and it had Rust on it, so I chose that. And then I create, for each of those tiles, I have like a hex. So the name A001 is the one that hex card gave it. And then I say, okay, the sides are grass, 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 ocean, ocean, ocean. And then I did that for 64 tiles. My hands actually hurt in the end because I had to write so many damn like tiles. Look at the PNG, like, okay, here's the, okay. And I actually like ran into me having actually put the wrong thing in there last week. So it was manual, but sometimes you gotta do the manual thing because it's a one-time thing. And here's how I spawned my board in the beginning. I have like a ring of radius something up to a board size. And then I iterate through that, iterate through a ring on that radius for each like radius. So first and then second ring, then fourth ring, iterate over them, choose a possible tile. I get the possible hexes for that coordinate, and then I choose a random one out of that possibility space, set that on the board, and the rest is just getting the asset, putting it into live world. I have this board, a board which is, my world, and then I put it into the graphics system afterwards. But we're gonna like focus on the board world.
But it's pure stochastic. You have infinite amount of any kind of piece.
Yeah, it's purely stochastic. At least this implementation, and this is not wave function collapse, by the way. I'll come to that later. By the way, I'm using a library called Hex2D. It does all of the like hex coordinate math stuff. I've done this before in Unity. It's fun to do, but there was a crate that did it, and I just grabbed it off the shelf. So that's what does the thing of, I create a ring with this radius going around this direction, and then iterate over it. That's what that library does. And it has coordinates as well. Coordinate spaces for hexagons are actually quite interesting because you have multiple ways of doing a coordinate system. One of them is actually like a 3D projection into 3D of cubes. It's really cool. I just didn't want to do it. I had done that. Go read Red Blob Games. Red Blob Games. If you want to learn more about it, it's a really fun thing to do. Yeah. And then like these are like the high level bits now into the lower level. So how do I get the possible hexes for a coordinate? I just have like a where is it? I have this get possible matching hexes that goes through a list of possible hexes, which is just all of my different tiles. Filters the ones where the sides match. So I can actually, I forgot a slide where I show you this match sides. There's a bit of things in there, but I figure out where can these sides match, and then collect it, filter it. And then for the get possible hexes for coordinate, I get the possible matching hexes and then get the matching rotation for that. So it's a bit of a ball ache, but that's how I did. Yeah.
So you mentioned before that you had a concept of a hex not being set in stone.
Yeah.
So in the iteration at the bottom, is that iterating over things that are determined, or do somehow?
Yeah. The possible hexes.
Can you repeat the question?
Sorry.
I can also
Repeat it.
So for the mic.
Yeah, but repeat it so I can repeat it because I forgot already. I had my answer already queued up, so.
So you have an iteration in your code where you try to find the matching hex.
Yeah.
The ones you iterate over, are they with all sides determined?
Yes. Yeah. This possible hexes, which is part of the self, which is a board. The possible hexes is all of the tiles that I got from this hex run objects. So it's all of the things where I have tiles for. That's the possible hexes. The other like hex is the one that's not been determined yet. So this hex sides, that can be like half determined. So some of them can be any, and then I find the things that can match that in the possible hexes. Yeah. Up here, when I then set in stone a specific coordinate in the hex map grid, I then have to like propagate the constraints to the rest of the thing. If this is blue, then this needs to become blue, right? And vice versa. Like if that's green, the next coordinate down needs to be green on that side. So this is a bit of like annoying stuff. So if I set in stone a specific coordinate with a specific hex, I have a hexes struct or the member that's just like a coordinate system of all of my the actual like hexes. And then I go like round the neighbors and then find for each of the coordinates in that neighborhood, I find the corresponding hex and then set the like opposite direction to that. Yeah. That's all it is. Questions? I'm not that fond of this, but yeah, such is life. Actually, one thing that I thought I should show, because someone asked for it, I think. Wait. Board. How do I figure out which sides match? Yeah, sure. Enhance. I haven't found like a really efficient way of figuring out if two like arrays can match and where they match. So what I've come up with is I put two like arrays of possible one of I put the two of side one together, a side one and a side one, and then I window the other one going through those two, and then figure out where in that I can match. Because like you need to also, you can't just you need to figure out where the now. Well, let me go back. You need to actually, this can rotate, but then this becomes this. So you need to do it doubly. I haven't figured out a good way of doing that. If you're clever, come at me. Question?
We'll do that.
Okay. So this was my like first implementation of it. I just go around in a ring and find what can I put here, and I put it there. Nice. And this is the part where I actually gotta confess to something. This was my implementation like 2 weeks ago. I thought this was wave function collapse when I said to Simon, "Hey, I'll do a talk on this," and then I looked at my code and was like, "That's not wave function collapse." I thought about like putting an asterisk. I was like, no, those are too many asterisks. So I went and implemented, and you're gonna be with me on that journey. How much time do I have?
You just keep going.
Yeah, okay.
This is getting good.
Talk really fast, so don't worry.
Yeah. So wave function collapse. Who knows about it? Like hands up. Oh, some. Yeah. It's an algorithm inspired by quantum mechanics for generating like tile or textures based on like small samples. So you have like a small sample here, and based on that and some rules, you can generate a bunch of like different ways of outputs and just infinitely generate tile or textures based on this. And it's actually quite cool. Like for example, here you have this example input, and you can generate a bunch of stuff. It's really good for bit textures like those. But it's also you can use it for 3D textures. There's a couple of games, Bad North, if anyone's seen that. That's using wave function collapse, and it's 3D as well. You can use it with like an example image, or you can just generate tiles specifically for it, and then generate images based on those tiles. And that's what I'm doing. It's called the simple tiled model, and I don't have like an example input of hexes that I could use, and I don't know if I can actually do it because hexes aren't self-similar. So I don't know if you can like do the same tricks. I'll show you one of the examples they have on their GitHub of it. It's actually really, really pretty. Do you see it? You can stare at this for days. But it's a way of generating textures based on tiles or inputs. And the way it works is first you read the input bitmap, like the, oh, sorry.
You said you're doing a simple thing, so you're not inferring from an example,
Exactly.
but you're still then manually constructing the rules that would be inferred from the sample.
Yes.
Yes.
Yeah, but I don't think you can create a single sample where you can generate, you can't tile a hexagon with hexagons. Do you know what I mean?
Yeah, but you don't. I don't think you need to. But that's.
Yeah. Okay. Cool. And also, I have these tiles already. This was my this is what I want to do. I don't want to generate stuff from a sample. I want to generate with these tiles. But how it works. So first, you read the input bitmap and count like tiles from that bitmap. We already have tiles. Then you, sorry, question? Then you create an array with dimensions of the output called wave in the source. Each element of this array represents a state of an n by n region in the output. I'm just going to read out. A state of an n by n region is a superposition of n by n patterns of the input with Boolean coefficients. So a state of a pixel in the output is a superposition of input colors with real coefficients. False coefficients means that the corresponding pattern is forbidden. True coefficients means that the corresponding pattern is not yet forbidden. We create a bit mask for each cell with a one where the cell that tile is allowed. That's what I'm gonna do. This is the simple model. You also have an overlapping model where tiles can overlap each other. I'm not doing that. Then you initialize the wave in a completely unobserved state. I like how they really like gone way into this. This is quantum mechanics. You put ones in the bit mask. You repeat the following. Observation. We find a wave element with minimal non-zero entropy. If there is no such element, if all elements have zero or undefined entropy, then break the cycle 4 and go to step 5. I find the cell with least ones. And I think this is the correct way of interpreting entropy in this case. They even use Shannon entropy, which is just how many ones, I think. So you find the cell with least n ones. You do a one count. Then you collapse this element into a definite state according to its coefficient and the distribution of n by n patterns in the input. Yeah, we choose a tile for that cell. This is where you can do it more complexly, where you have the distribution of n by n patterns in the input. So if the same like input is multiple times, or if the same tile is multiple times in the input, you give it a higher rank. But I'm not doing that. And then propagation. We propagate information gained on the previous observation step. And that's this. For all the surrounding cells, I update the bit mask with the new constraints based on that chosen tile. And then by now, all of the wave elements are either in a completely observed state or in the contradictors to whatever. We're done. The map has been like completed. So here's my first attempt. It looks like the same now. Instead of just looping around in rings around the center, I get the minimal entropy coordinate. I get the possible hexes for that coordinate, choose one of them and set it. It's a bit messy. This was my first attempt. I'm just banging out code. I needed to get done in 2 weeks. So how do I do this? Like get minimal entropy coordinate and the possible hexes for coordinate. this is what I first started with. So I actually didn't show you before, but this was my board definition up until this point. So I have like horizontal size, vertical size, and then a vec of hexes, which is like my board. And then the possible hexes, which is the tiles that I can choose from. And now I have created this beautiful wave function, which is a vec of possibility space. And a possibility space is just all of the different, it's a vector of all of the different hexes and all of the different possible rotations. So I save a hex times 60 for each cell. I'm just doing it the stupid thing first. And then disregard that. For entropy, I'm just, for all of the rotations that are possible, I accumulate that over the flattened array. And then when this trim, I'll get to how I use that later, but it's basically trimming the possibility space of a given hex or a given wave function. So I go and like retain all of the hexes where I can match sides, and then I remove all of the iterations that aren't possible in that. I hope that everyone sees how inefficient this is. I kind of do the same thing with when I set. I clear the wave function for that bit, and then I collapse the wave function on the surrounding tiles. And the collapse wave function is just the trim you saw before. So Is this going too fast? That's my performance metrics. 9 gigabytes of RAM to run that.
You've got to do something with it these days. It's just sitting there.
Yeah, it's just sitting there.
You download it if you need to use it.
Yeah.
You have 60% RAM left.
Oh yeah. But my idea was, let me just try. I can always like optimize it.
You can always buy more RAM.
I can always buy more RAM. And now you're going to see how I optimized it. Making improvements. Is it too small? Sorry? Okay. First of all, I slimmed down the board. So now a board is a hash map of coordinates, and then for each of the coordinates there's a cell. And each cell is a hex and a possibility space for that hex. And a possibility space is a list of valid rotations corresponding, so that an index into this vec corresponds to an index here. So if a rotation is valid at index I can look up and say, okay, that means that possible hexes at rotation in there is valid.
Silly question. Rotation represents all possible rotations of all tiles.
Exactly. It's a bit clipped actually, so let me just, because it's right here. So what a rotation is, it's a U8, it's a bit mask, where there's a 1 if a given rotation is valid. And then I set it, have a bunch of like bit computations for checking or setting, clearing, and then entropy. Like I just count once. Question for the crowd: count ones. Why in the standard library does that count return a U32 for a U8?
Because it probably doesn't matter register-wise.
Yeah, probably.
They also return U32 for any bit size, like U8 bits.
Okay.
You can tell U8.
Yeah. Yeah, I just found it funny. Like I think it's probably most optimal. I guess the pop count gives you a like U32 or oh, my slides are really good. Okay. I'm just gonna drag that up here. And then for collapsing the wave function that we saw before, yeah, let's see. Yeah, I go through that. I go through the valid rotations at that hex, and then like set it to 0. No, actually, I do the reverse. I clear it and set it to ones where they actually match. Do the rotation. Yeah. That's a lot better. 500 megabytes, and that's on like an infinite grid of hexes and 6%. So yeah, this was my last like attempt at it. Yeah, for the last bits, optimize like next steps, optimizations. Like I love clone. It's my favorite thing to do. There's a lot of clones around, but as you saw, it doesn't really matter. One of the things I think matters is I use a texture name to look up in the in the list of my list of textures, and I could use a handle instead, which is a better thing. And last thing for optimization, group theory. Do we have any mathematicians who can tell me, like, are there anything in like the symmetries of hexagons and the mirroring where you can quickly find out if two hexes match? No. Then features. I'd like to do serialization and deserialization to save maps. Maybe some interactive generation, because you can just choose a specific tile and then let the algorithm go nuts. Choose a tile and then that feedback loop is actually kind of nice. Then last, a mirror symmetry. Like you can actually just flip as well instead of just rotating. That gives another symmetry. And the textures just allow you, like not all textures can be flipped without making them nonsense, like text. You can't just flip them, you can kind of rotate them. That looks kind of nice. But it would be, mirror symmetry would be another way to like enlarge in the possibility base. So yeah, that's it. Questions? Sorry, he wanted to clap. Yeah, questions? That was a lot, right? Yeah.
Do you still want to make it into a real game from here, or it's just ambition to play around with generating maps now?
I kind of like, I just go with what's fun. I just found this like figuring out how to solve the constraints was just fun. So I had my game and I was like, I'll go down this route and find out what's fun here. That's kind of how I have programming as a hobby. So I don't think I'll make it a game, but maybe it'll become something else. Yeah.
You just need to tell me you're making a game, then you'll have it ready in 2 weeks.
Oh yeah, yeah.
Yeah, your next title should be how I made this into a game.
But it wasn't actually that hard. I had all of the building blocks already. It was just a matter of like,
You have a game engine.
yeah, I have, yeah. I had all of the tiles. I had ways of finding the matching rotations. I just needed this get entropy and get the least entropy. That's kind of the crux of what I needed. Yeah.
Do you think you'd get any speed up if you? Okay, I mean, you've already improved memory and CPU quite a lot. Do you think you'd be getting any speed up from switching from hash map to like fast map, whatever else they're called? Because the default hash map is, I think, zip hash, and I think it has like it's really good, but I think it's like overly redundant. So maybe you could switch to faster.
I don't know. I was thinking of actually just maybe doing a priority queue instead, because I need to find the least entropy coordinate. So if I each time I update it, I then update the priority queue instead, then that's fast. Yeah. The reason why I actually changed it from vec of hexes into a hash map was it kind of allowed this sprawling thing. I wasn't constrained to the like squareness of a vec. I could go into negatives. I could have suddenly a negative coordinate without having to index into a negative with a negative. So that's actually the main reason. Yeah.
I didn't read the code properly enough to know if this question makes sense at all, and if it's just a question of preference, or it is a question of preference. I know that.
Yeah.
If it's relevant, that is. I saw quite a few places in the code where it looks like you're using for loops when I would probably have attempted to use an iterative chain.
Yeah, I love iterators, especially like the what is it called, iter-tools crate. Just being able to have an iterator and then doing crazy things on it. I think my main idea for using for loops is when I'm doing mutation. I just feel like that's fits better in a for loop.
Okay. Yeah.
But yeah. But it's
I spotted a manually implemented find.
yeah.
I might have misread the code.
I think there is a manually implemented find. Yes. Where did you see it?
I don't know. I barely see him. Too bad eyesight.
But there probably was. Yeah.
More questions?
Yeah. Have you been able to run it in the browser as well?
No, because like my pipeline complains that it isn't formatted correctly, because it wasn't my priority, and I had my old version already running, and I thought it would be kind of nice to be able to show you the difference. So it wasn't a priority, but it shouldn't be a problem.
The first question you answered was about the holes. Have you thought about adapting the algorithm back tracing and fill the holes?
That requires you to do backtracking, which you can do with like wave function collapse. But in honesty, it's just the fault is at the tiles instead. Like there's just not enough tiles for this to be good enough.
Mirroring might help.
Yeah, mirroring might help. I think so too. Yeah.
Asking the guy to make the missing.
Yeah, and actually, like mirroring would just be another bit in the rotations pit mask.
You can mirror across 6 axes.
Well, a mirror, the mirror symmetry is only once, and then the rest is just a rotation on that mirror. But I guess you would need the mirror bit and another bit as well.
That's fine.
Yeah, but then how
many rotations do you have? 6?
the problem is, how do you represent that? Now, like, my entropy is how many ones, but now is the mirror bit and then times the rotations.
You need 12 bits for that.
Yeah.
Just to have it like one way and the other way, I guess.
If you're doing it the fast way, but if you're doing it the memory compressed way, you could just do 1 bit for the mirroring and then calculate the entropy in a different way. So you would, if you would say the number of rotations times 2 if the mirror bit is set.
Could do integers, negative ones are mirrored.
Yeah.
In the same way, like the first bit is like.
Yeah. Yeah, but how do you elegantly like do the entropy calculation?
You can do 2 more bitwise.
Yeah.
Yes, one to get the bits value in a register, and another one to not. The last one's not bitwise, but to double.
Yeah.
Values if it's set or not.
It can be done. You can make it fast.
Also scrolled through the Bevy, like this code.
Yeah.
And looked for showcases also with the wave function collapse. One tried to do a 3-dimensional function collapse, and he's using something called Capsuna, which basically says support for custom grids or arbitrary dimensions and topology.
Yeah, there is, like, I think there's a crate for wave function collapse as well. That does like a lot of abstract stuff.
Yeah, just the shorthand.
Yeah, WCF.
But apparently he didn't want to use that because that was a lot of complicated and didn't really fit whatever Bevy was like doing.
Yeah. To be honest, I haven't looked at that. I've
Just a note.
Yeah.
If you want to take a look closer.
There is also implementations that do it way more abstractly, like topologies, as you say, and symmetries, and like different not tiles, but yeah, you can do a lot of stuff with wave function collapse. You can also do backtracking and setting stuff in stone based on, or having given like tile be more possible than others, but not, it's not just ones or zeros, but a possibility space. So for example, roads could be more possible than other things. Yeah, I just did the simple thing.
All right, let's round it off here. Thank you very much.